In presentation 13, following the steps shown in the charge table, I did a walkthrough of the calculations that were necessary to create the charge summary table for Class 2 ore material. In this presentation, I will be following the steps given in the charge table, taking you through the calculations in regards to Class 3 ore material in order to create the summary table of flux ingredients and quantities used to create the ideal slag and the required lead button. The calculations will be the same for Class 1 ore or concentrates. This case example is based on a Class 3 ore from the IOCG group of ore bodies. IOCG stands for iron oxide copper gold. Class 3 ore does not contain any silicates or sulfur complexes, but are high in base metals that are in their highest oxygen state. That is to say that they contain more than a single oxygen atom, such as calcium oxide. These gold-bearing ores usually constitute a mix of magnetite and or hematite and hydroxylapatite A, or simply apatite for short. This case example represents a Class 3 ore containing 70% magnetite and 30% apatite. This first step is basically the same as would be for a Class 2 ore. However, with Class 1 or Class 3 ore, the sample is usually weighed out to be 0.5 of an assay ton. Sometimes 1.0 of an assay ton is used. Some textbooks will also tell you that 0.1 to 4.0 assay ton is possible, as long as your crucible is large enough, as well as other factors which have been previously discussed in past presentations. In this presentation, it will be assumed that the individual conducting this fusion is using a weight of 0.5 assay ton, which, as shown, is 15 grams rounded off. In the last presentation, a subsilicate degree was used. The monosilicate and subsilicate degrees are used for the Class 2 ore types. But for Class 1 and Class 3 ores, a bisilicate degree is and will be used. Step 3 is the same that is used for the Class 2 ore types. It is the simplest of all calculations. The amount of sodium carbonate that is used will be equal to that of the weight of the sample. In this case example, it will be 15 grams. This step is a little different than that which was used for the Class 2 ore type. There is no silica in a Class 3 ore. In this case example, there is no alumina, just base metals. 30 grams of lead oxide is still needed for the 28-gram button. However, for the slag, 1 times the ore weight is the criterion. Therefore, 45 grams of lead oxide will be used in the charge. Before moving on to calculate the amount of silica, flour, or niter, some data is required. The ore sample, having a weight of 15 grams, contains 70% magnetite and 30% apatite. This equates to 10.5 grams of magnetite and 4.5 grams of apatite. The molecular weight of both constituents must also be known. Those calculations are shown. A balanced chemical equation needs to be written, and the molecular weight of each oxide has to be calculated, as well as the atomic weight of the lead is required. Notice the balanced equations. The iron oxide is an oxidizing ore and will inhibit any formation of the elemental lead. This is shown as the lead being the reaction side and the lead oxide in the product side. For the apatite, it is a reducing compound, and therefore the lead oxide is shown in the reaction side. The elemental lead is on the product side. Now keep this in mind, as it will be used in the calculations for the reducing and oxidizing powers in respect to the requirement of either flour or niter. Regarding the calculations for the required amount of silica to be used, each item has to be calculated separately, as was done with the Class II ore material. It starts with a balanced equation as shown in the previous slide for both ore constituents. A reaction equation for each base metal oxide and basic flux material is then written and calculated for the needed amount of silica. The calculations are the same as for the Class II ore material as shown in regards to the magnetite portion of the ore sample as well as the soda ash and litharge. The calculation for the apatite constituent is shown. Once all the calculations are complete, the total amount of silica needed is simply the total of all the calculated amounts needed for each basic constituent. The actual required amount is calculated as being less 1/3. For this case example, the 1/3 will be replaced by the required borax. As mentioned, 1/3 of the needed silica is replaced by the addition of borax. Since a bisilicate degree is used for the silica calculations, the borax equivalent constant of 1.7 is used for the borax calculation. Since the needed amount of silica is 25.74 grams and 1/3 is being replaced, the calculated amount of borax required for the bisilicate degree is 14.57 grams as shown. As shown in the reaction equation, the magnetite is an oxidizing compound. Since lead oxide is added to the charge, any lead oxide that would normally be reduced by a Class II ore will not be reduced, but inhibited. The lead button would not be formed. As for the apatite, it is a reducing compound and the lead button will start to form. Flour, in this case example, will be needed to reduce the required amount of lead to form the lead button. As the magnetite is oxidizing, the required amount of lead to produce a 28-gram button is calculated to be 56.21 grams. However, there will be a small amount produced by the reducing power of the apatite and must be subtracted from the required amount. Since the formation of the lead button is still inhibited, flour will need to be added. The reducing power of flour is 11. Therefore, 4.88 grams of flour will be required for the formation of the lead button. Since this is a Class III ore case example, it did not contain any silicates and was basically a high oxide ore. Niter was not required and flour was added to reduce the litharge to elemental lead. Therefore, additional soda ash was not required. As there were no contaminants present, no additional requirements were necessary that would have been listed in Step 9. All that is needed is to place the results into a charge table. In presentation 13, I walked through the calculations for a Class II ore, following the charge table that was introduced in presentation 12. In this presentation, I walked through the calculations required for a Class III ore, which would be the same for a Class I ore sample. You should now be familiar with the process of calculating the flux material for a crucible fusion. The next presentation will be on scorification, the alternate to crucible fusion. If you like this edited video presentation, or if you know someone who may benefit from this series on the fine art of fire, do give it a thumbs up, a like, and a share. I'm Rob Boyko, Boyko Mineral Exploration, and I thank you for watching.